My name is Dr. Ali. I'm the head of the Component Space Evaluation and Radiation Effects section at the European Space Agency.
My name is Nat Carthew. I'm the EEE Components Laboratory Manager at the European Space Agency.
In 2013, Gaia, one of ESA's cornerstone missions, was launched to make the most precise three-dimensional map of our galaxy. Gaia will survey 1 billion stars, and it will generate enormous amount of data, approximately 100 terabytes during its mission lifetime. The Payload Data Handling Unit, or PDHU for short, also acts as a hard disk for the spacecraft to temporarily store the scientific data for further transmission to the ground station.
During the preliminary onboard test, the PDHU proto-flight model failed due to a problem with the memory module. The main concern was that this might be a general manufacturing issue rather than a one-off component failure. In the worst case scenario, parts might have to be changed on the proto-flight model, which would cause delays to the project and might even cause delays to the eventual launch date.
The analysis and tests that we perform are often destructive. That is, we open the components and we section them in many smaller pieces. However, before we start a destructive test, we typically use one of our core equipment in the laboratory, that is the 3D X-ray tomography machine.
When we first received the memory module, we didn't know how it was assembled or what the internal makeup of it was. So we subjected it to a 3D X-ray scan. This involves taking a series of 2D X-rays whilst rotating it in front of the X-ray source, and then using those 2D images to build up a 3D model of the component.
The memory module is manufactured by stacking memory devices on top of each other. This stack is then placed in a package and resin poured into the package to fix the memory devices. The package is baked to cure the resin. With 3D X-ray tomography machine, we can virtually and non-destructively section through the device and also remove material based on the density. When we receive the memory module, we suspected cracks in one of the memory devices, but we were not sure of the location of the failure.
We found that there were air bubbles within the module, and during soldering processes this can cause what's called the popcorn effect, where a sudden release of water vapor can cause cracking within components inside the module. We subsequently opened this part up and ran it through the scanning electron microscope and found that the topmost die was cracked from end to end, which is what caused the module to fail.
The most probable cause of the failure related to the process of soldering the component onto the circuit board and not to the memory module manufacturing process. The faulty memories were replaced with specific attention to the soldering process. The proto-flight model was then reassembled and put through a rigorous test campaign, proving the reliability of the system. Since 2013, Gaia has successfully collected scientific data, and the memory devices are working perfectly in the system to ensure that Gaia provides the most precise three-dimensional map of our galaxy.